Hey guys. Okay, I think you can see this. I don't know, I'm trying to use YouTube to record it, so I'm just gonna record a little bit and then we're gonna see. Okay, so where I stopped last time was we had x squared minus 9 and we were trying to find the zeros. So what we do is we set x squared minus 9 equal to 0, and then we solve that. So we add 9 to both sides. X squared equals 9. How do you solve that? You take the square root of both sides, and we got x equals 3, but we have to have a plus or minus anytime we take the square root of both sides. So we really get x equals two answers, positive 3 and negative 3. And those are two real numbers, right? 3 and negative 3 are real numbers. So we have two real zeros. Real zeros are x-intercepts. The same, if you say it backwards, it is not the same. X-intercepts are not equal to zeros. Only real zeros are x-intercepts. We have to have that word real in front. Otherwise, if we kind of, I was chopping something and I hurt my finger, so that's why I have a Band-Aid. But anyways, if we take off that word real, zeros equals x-intercepts is false, completely false. That's what I have written in purple right here. And we're gonna see that in the example C, okay? It's gonna be exciting. Now, whenever we were going to graph it, what we did was we said, okay, we have two x-intercepts, x equals negative 3 and positive 3, so we plotted those. And then since those are equidistant from the origin, I knew the vertex was going to be right in the middle of it. And so in order to find that, that's also the y-intercept. In order to find the y-intercept, we plug in x equals 0. So we take our function, everywhere we see x, we put in 0, and we get back negative 9. And then we get back our y-intercept of over 0 down 9. So we plot that. We draw the nice little curve. Notice that on my x-axis I counted by 1s, 1, 2, 3. But on my y-axis I counted by by 3s, 3, 6, 9. So that axis is, the tick marks are a lot closer together than the ones on the x-axis. So if you had your tick marks equidistant on both axes and counting in the same units, so this one distance would be 1, and you do the same thing going down, 1, 2, 3, your negative 9 would be like way the heck down here, and your parabola would be a lot skinnier. Okay, anyways, I'm pretty sure that was Nolan. Sorry about that. But now what we wanted to do on this whole thing was we wanted to look at the zeros. Okay, so x is a 0 if when you plug that number in you get back 0. Okay, and the way you find those zeros is you set your function equal to 0, like up in this previous statement. If you set your function equal to 0 and solve it, you get back your x values that are you get back your zeros. Okay, so that was the first thing that we wanted to do. Then we wanted to look at the graphs, and the last thing we wanted to do was compute bx squared minus 4ac. B squared minus 4ac is the discriminant of your quadratic formula. So I'm going to go ahead and do that at the bottom. So let's grab a different colored marker. I'll just use a blue pen. Okay, so my function is y equals x squared minus 9. So I need to figure out what is my a, what is my b, and what is my c. A is the number in front of x squared, so that's just 1. B is the number in front of x, but we don't have an x term, right? We don't have a linear term, so our b is 0. C is negative 9. Okay, so if I was to write my ax squared plus bx plus c, right? If I was to write my standard form, ax squared plus bx plus c, it would look like 1x squared plus 0 times x plus negative 9. And now you can see a is 1, okay, b is 0, and c is negative 9. Okay, anyways, so let's compute our discriminant, b squared minus 4ac, and we get 0 squared minus 4 times a times c, and we get back that that is 0 minus 4 times negative 9 is a positive 36. Okay, so he's a positive number. And that is what we want to know, okay? And we're going to use this information later. So this is more like just a side note, but he has to do with how many zeros you have. Okay, how many x-intercepts you have, not zeros, I'm sorry. How many x-intercepts you have. Okay, I'm going to pause it and we are going to see about recording the next two.